Alright, an introduction to petroleum fuel facility atmospheric storage tanks. J. Paul Geyer, PERA. Alright, introduction, general requirements, general criteria, horizontal above ground tanks, single wall steel. Horizontal above ground tanks, double wall steel. Horizontal above ground tanks, fire resistant. Horizontal above ground tanks, protected tanks. Above ground vertical storage tanks. 9 underground horizontal storage tanks, underground vertical storage tanks, cut and cover, brutencies, heaters, underground storage tank spill contamination system, above ground tank spill contamination system, 15 miscellaneous use of tanks, shipboard offload fuel storage tanks. Alright, this do not purchase. This publication is adapted to the Unified Facility Criteria, United States government, which are public domain, have been authorized for unlimited distribution, and are not copyrighted. Alright, introduction. The discussion provides guidance for the design, bulk storage tanks, operating storage tanks, ground vehicle fueling tanks, miscellaneous use tanks, product recovery system tanks, contaminated fuel storage tanks, jet engine test cell fuel storage tanks, design guidance on issues related to storage tanks such as protection, loading, coatings, product recovery, spill contamination systems, also covered in this chapter. Chapter generally apply to new tanks. 2. General requirements. Do not start designing any fueling system without first being completely familiar with the general design requirements. 3. General criteria. Design liquid fuel storage tanks comply with the operational requirements, particularly where command have jurisdiction on facility. Ensure the design is appropriate for the mission facility. Conserve the operational requirements of the user of the fuel. 3.1 Materials. Above ground storage tanks shall be constructed of steel and concrete and encased steel. 3.2 Protection. Provided protection prevents, preserves product quality, ensures minimal loss of evaporation, dilution, leakage, substitution, theft, contamination, attack, sabotage, fire, damage to the environment using above ground steel tanks unless the mission facility. Other practical considerations to take above ground, underground tanks be used. Cut and cover buried vertical tanks are not normally used for the conventional continental United States. Cut and cover tanks may be required dispensing system located near clear zones, explosive cordon areas. Conduct economic operational mechanical analysis, remote locating pump house and system from hydrant system versus construction cut and cover tanks for tanks located in areas subject to flooding in accordance with the National Fire Protection Association 30. 3. Design requirement. Fuel storage tank facilities provide operating reserves to supply fuel type. The size of the storage tanks depending on safety and economics. Terrorist activity locality intended to use provide separate storage for each type of each type and grade of fuel or aviation activities provide minimum of 2 tanks for each of the fuel. 3.4 Storage capacity. The capacity of the size of each of the fuel storage tanks is based upon the logistic missional requirements of the facility. Any other facility to be supported from and different stated for volume of each fewer tanks of larger size will result in the maximum economy. The appropriate owner and approval will determine the number of the size of the tanks required. Provide a minimum of 2 tanks aviation activities for each of the type of the aviation turbine fuel to receive isolate new receipts until tested and checked for quality quantity while the facility continues to function and while stock is on hand, and general capacity for the individual tank should not exceed 50% of the total storage volume required for each type and grade of fuel. Do not provide tanks with capacities greater than 100,000 barrels, except when larger tanks are specifically authorized by the owner. 3.5 Tank spacing. Vertical tanks. Provide minimum distance between the shell of the vertical tank, both above ground and underground, for not less than 1 diameter of the length larger than of the tank. 3.5.2 Horizontal underground tank. Provide a minimum clearance between the shelf and the adjacent horizontal underground tanks of 3 feet. Horizontal above ground tank, single wall, double wall, steel, non-fire resistant, non-protected. Provide a minimum clearance above ground horizontal tank with a capacity of 50,000 gallons or under as follows. Arrange tanks as prior to minimum 5 feet between the tanks in each pair and 10 feet between adjacent tanks of 2 pairs in the same row. Same adjacent groups of more than 2 pairs in a single row with at least 20 feet, 6 meters between the nearest tank of the groups. Provide a minimum end-to-end spacing bank between tanks and longitudinal rows of 20 feet. Provide a UL name plate on the tank stating where the tanks is approved for the material and service. Additional requirements listed in paragraph. Tanks located in the facility governed by the National Fire Protection Association 30A. Submarine and motor fuel dispensing facilities should comply with the National Fire Protection Association 30A. Alright, 354 horizontal above ground tanks, fire resistant, provide minimum clearance spacing between fire resistant secondary contaminated above ground horizontal tanks in compliance with the National Fire Protection Association 30 and 30A as applicable. National horizontal above ground tanks protected by a minimum clearance space between protected secondary contained above ground horizontal tanks in compliance with the National Fire Protection Association 30 and 30A as applicable. Distance from a building and property line, locate tank sufficient distance building of the property line to prevent ignition vapors from the tank and protect buildings that are occupation contact with the damage by tank fire. Assume the maximum internal pressure of the fire exposure will not exceed 2.5 psi gauge with the minimum compliance requirements of the following paragraph. 361 underground tanks. Locate underground tanks with respect to buildings. Similar structure of the soil pressure created with the building foundations will not be transmitted to the tank pumping facilities, which are often directly above the underground tanks, are accepted to locate horizontal cylindrical tanks less than equal to 12 feet diameter, not less than 10 feet from the nearest point and adjacent building over the property line. Locate vertical underground tanks at least 25 feet from the nearest point, adjacent building, and 50 feet from the nearest property line. Above ground tanks. Locate above ground tanks with consideration fire safety, fire consideration to prevent ignition vapors from the tank of the second, consideration to protect the building and occupants' contents from the damage of the tank fire. As a protective measure, provide all above ground tanks with some of the emergency venting of the fire exposure in accordance with the National Fire Protection Association. In the following, it is assumed that all tanks are constructed and equipped with a minimum maximum internal fire exposure will exceed 2.5 psi or 17 kilopascals. Required minimum distance above ground tanks or buildings or property lines are as follows. Tank size and types are not protected fires, non-protected fire resistant, containing petroleum fuels with flashpoints less than 100 degrees Fahrenheit or 38 degrees Celsius, 100 feet from or one tank diameter which is greater, with an exemption of the tanks and one located in the facility governed by the National Protection Association 30A, such as marine motor fuel dispensing, should comply with the National Fire Protection 30A1 and Criteria 1. Alright, tanks protected virus and non-protected fire resistant, containing petroleum fuels such as flashpoints of 100 degrees Fahrenheit or greater in accordance with the following. Show the tank capacity 275 gallons or less, and it goes up to 50,000 in one or more. Minimum distance near property line in feet, and increments of 10 until you get, minimum distance from nearest building in feet. For above ground fire resistant facilities governed by the National Fire Protection 30A and 30A guidelines. For above ground protected tanks of the National Fire Protection Association 30 guidelines. Protected tanks located in a facility governed by the National Fire Protection Association 30 using marine motor fuel dispensing shall comply with the National Fire Protection Association 30A1 Criteria 1. Alright, 737, the distance of the railroads, and power lines. For tanks located in the facilities governed by the National Fire Protection Association 30A and 30A guidelines, use 38 guidelines. For all other storage tanks, minimum distance adjacent road and railways and railroads, overhead electrical power lines are as follows. Underground tanks, space and clearance for the underground tanks shall be a minimum of 25 feet for the regular travel road and highway does not include tanker farm utility fire access road. 25 feet from railroad spur tracks not used for traffic, not less than 100 feet for the main railroad tracks carrying through the traffic, 100 feet, 50 feet from overhead electrical power transmission distribution line wires. 372 above ground tanks. The greater 100 feet, the one more tank diameter, generally regularly traveled roads and not including tanker farm utility fire access roads. 50 feet for the railroad spur with the tracks not used for the traffic. 200 feet from main railroad tracks carrying through road traffic, 50 feet from overhead electrical power transmission distribution line. 3-8, distance from tank to truck, tanker car offloading loading facility. Tanks located in the facilities governed by the National Protection Agency C30A and 30A guidelines. For the fire-resistant protected horizontal above-ground tanks, underground tanks provide a minimum separation of 25 feet with the tank truck with the tanker car offloading and loading facility. For other tanks, provide a minimum separation of 50 feet from tank trucks to tanker car offloading and loading facility. Interior coatings. To extend life of the steel storage coat and new tanks according to the following guidelines. Vertical tanks. All aviation diesel fuel marine F-76 additive low oil tanks interior shall be 100% coated with included floor shell and underside of the roof. Other products: coat on the floor on the underside with a fixed roof bottom of the 40 inches of the tank shall adjoining coating up to 100% of the requires economical justification, and the owner approval to tanks containing the E85 shall not be are not included in coated internal use of the roof otherwise approved by the owner. Horizontal tank. For all products, tank interior should be 100% coated. Tank coatings E85 are not to be coated internally unless they are used otherwise approved by the owner. For all products coated with the interior exterior carbon steel piping located inside of the tank and steel appurtenances inside all tanks. Carbon steel piping and steel appurtenances located inside of the tank containing E85 are not to be coated internally unless otherwise approved by the owner. Alright, 310. Exterior coatings protect the exterior surface above all ground steel tanks by coating in accordance with appropriate guide specification. Protect the exterior surface of all the underground horizontal steel tanks with a factory applied coating specified in appropriate guide specification. For protected tanks, exterior steel contaminants consider exterior fiberglass cladding and for extremely corrosive atmosphere and seaside locations. 311. Fill piping. Size of the pipe with the velocity does not exceed 12 feet per second at a minimum flow rate. Provides a minimum reduction flow of 3 feet or 0.9 meters per second until the filling inlet nozzle is completely subcharged or floating pan has lifted off its legs. 312. Vapor emission control system. Provide a vapor emission control system for tanks producing of a true vapor pressure of 0.7 psi or 5 kilopascals at more located air pollution control area of the discharge petroleum vapors is controlled or prohibited. Ensure the system has sufficient capacity to control the vapor discharge of the tank vents at maximum fill rate in conformance with local air quality regulations. Gasoline is to be handled provided with a minimum stage 1 vapor requiring vapor recovery piping of the stage 2. If not required, local state and regulations at time of construction concept connect stage 2 piping in the tank of the cap to the dispenser. 313. Strapping and tables. Provide the 2 American Petroleum Institute MPMS Chapter 2 strapping tables with all tanker cars greater than 5,000 gallons. Provide 1 table to the U.S. customary units reading 1/16 inch increment gallons and barrels, 1 metric units reading 2 millimeter increments, liters, and cubic meters. Provide electronic media data file to determine strapping table volume tanks of 5,000 gallons, larger physical measurement, not calculated values. Tables are calibrated critical measurement and professional by a certified professional engineer. For less than 5,000 gallons, provide strapping tables certified by a tank manufacturer that reads 1/16 of an inch. Increments in gallons or Alright, 314. Product recovery system. General design consideration. Provided pumps and piping and valves to tanks collect and store usable aviation turbine fuel, which would otherwise become waste for the operational maintenance activities. Consider product recovery system for other products, include a tank of fuel, like fuel, water mixture for the tank and equipment of the sumps and equipment to drain for the products over the tanks, the high point valve, low point drains. Any other equipment of the fuel and water mixture can be collected. Separate the fuel and water portion, filter of the fuel portion, return the operating storage tank to not discharge the water portion, surf the water without additional treatment and permits, or treat water portion as wastewater. For further DOD standards, design AW 782428. These systems are designed with a hydrant aircraft directing fuel system. 314.2. Product recovery tanks. For hydrant aircraft directing fuel system, provide a tank direct with the owner. For the other system, provide a tank at the minimum following appurtenances: level gauge, overfill protection level, control valve, high level, low level switches with alarms that controls a motor driven fuel transfer pump that returns recovered fuel back to the system through a hard pipe connection. Motor driven sump pump for emptying the tank. A manual gauging hatch event, and ATG system above ground product recovery tanks having capacity more than equal to 4,000 gallons do not allow the site flow indicators to be installed on product recovery tanks. Alright, 314.3. Vertical storage tanks. In addition to the product recovery tanks for a facility, all vertical storage tanks storing aviation turbine fuel shall include a product saver tank for electric pump unless the tank is equipped with a filter separated to remove the water from the sump. A product saver tank is a small above ground tank piped valve allow drawing of the water bottom storage tank, returning the product after the water has been separated, disposed in accordance with the environmental regulations. 1315. Registration. Register all tanks with appropriate state local agencies as required. All tanks shall have the nameplate installed in accordance with the API standard 650. Alright, 4. Horizontal above ground tanks, single wall steel. General design consideration. Small factory built above ground storage tanks are required with a horizontal tank limited tank diameter 12 feet or less, capacity of 50,000 gallons or less. Required tank to be welded steel and construction in accordance with the UL 142. Plastic and fiberglass above ground storage tanks are not allowed. Requirements of all horizontal above ground storage tanks shall be complied with the National Fire Protection Association 30. Chapter 22, above ground storage tanks. Tanks located in facilities governed by the National Fire Protection Association 30A, such as marine and motor fuel dispensing facilities, shall comply with the National Fire Protection Association 30A. Tank design requirements. Install the tank at the bottom slope downward toward one end of the slope of the 1%. Locate transfer pump suction piping in the higher end of the tank and locate the water draw off at the low end of the tank. Provide a water draw off lines each of the tank aviation fuel station fuel system arranged piping. The fuel in the tanks may be recirculated through the filter separator. Provide steel tanks and steel saddles, skids on according to the UL 142. The bottom tank is not more than 12 inches above the ground to avoid the need of the fireproofing. Mount steel supports and reinforced concrete foundation. Tanks shall be inspected in accordance with the STI SP001 or by an STI certified inspector prior to commissioning. Alright, horizontal above ground tanks, double wall steel, general design criteria consideration, limited diameter into 12 feet with less and capacity of 50,000 gallons or less, required a tank for the weld and steel construction in accordance with UL 142. No fiberglass above ground storage tanks are allowed. Main advantage of double wall steel storage tanks over single wall storage tank is a separate spill contaminant may not be required. Secondary contaminant types tanks can be used to provide spill control per National Fire Protection Association 30. If capacity of the tank is more than 12,000 gallons, the tank size may be increased to 20,000 gallons. If Class 2, Class 3 liquids are used, all criteria in the National Fire Protection Association regulations, appropriate application must be before. Secondary contaminant type of the tank is used with the separate spill contamination requirements for the double wall steel horizontal above ground storage tank shall comply with the National Fire Protection Association 30. Chapter entitled Above Ground Storage Tank located with the facility governed by the National Fire Protection Association 30A. Such marine motor fuel dispensing facility shall comply with the National Fire Protection Association 30A. Alright, tank design requirements. Before flammable liquid installation is require additional carboning contaminated based on the tank filling rates for the chance of the fuel spill entering a critical area. Install tanks so the bottom of the slope downward toward one end of the slope at 1%. Locate transfer pump and suction pipe at the high end of the tank. Locate water draw off at the low end of the tank. Provide water draw off in each of the tank aviation refueling system. Arrange piping so the fuel in the tanks may be recirculated through the filter separators. Provide protective bollards from the tanks not surrounding by dike. Bollards shall not be less than 4 feet 4 feet high, 4 inches in diameter of the steel construction. Filled with concrete or space not less than 4 feet on the center. Provided steel tanks with steel saddles and skids according to the UL 142. Bottom of the tank is not to be more than 12 inches above the ground to avoid need of the fireproofing. Mount steel supports a reinforced concrete foundation. Mount rectangular flat bottom tanks 40,000 gallons or greater and 12 inches above ground, above grade to allow inspection maintenance for the tank at the bottom. Required tank to be pressurized, pressure tested after installation. Tank shall be inspected in accordance with the STI SP001 by STI certified inspector prior to commissioning. Primary tank constructed of stainless steel is permitted when required. Required support channels with anchor holes and earthquake, hurricane, fluid resistant to tie downs. Requires steel to be minimum thickness of 3/16 of an inch interior carbon steel tank. Alright, 6. Horizontal above ground fire resistant tanks. General design. When small 250 to 20,000 gallon tanks above storage ground is required that their clearance of the fire exposure problem with additional costs can be justified. Ensure the use of fire resistant storage tank. The main advantage of fire resistant tanks are over the single wall steel tanks is the separate spill contaminant may not be required for the vault system. Provides an added measure of the fire protection. Secondary contaminant type tanks can be used to provide spill control per 95 protection association 30. If the capacity of the tank is no more than 12,000 gallons, the tank size may be increased to 20,000 gallons. Class 2, Class 3 liquids are used. All criteria of the National Fire Protection Association regulations for the appropriate application must meet this before secondary contaminant type tank is used. Without separate spill contaminant, required tanks to be factory constructed with UL 142 welded steel primary tank. Tanks may not be used in an application where, in addition to the above considerations, construction on a separate spill contaminant system for the secondary contaminant purposes would have negative impact on the operation and or aesthetics. Tanks located close to the building or integral fuel dispensers must be UL listed secondary contaminant tanks, utilizing steel inner and outer tanks that can provide interstitial containment of both pressure and testable, verifiable. Such tanks usually have the fill-in regulator insulating concrete, ensure the 2-hour fire rating meets exceeds all requirements of the National Fire Protection Association 38 for the fire-resistant tanks and provides minimum 2-hour fire rating in accordance with the 2080. R62 tank design requirements for flammable liquid insulation require additional curbing contaminated based on the tank refilling rates. If there's a chance of fuel spilling entering the critical area, install the tank at the bottom slope downward toward one end with a slope of 1%. Locate transfer pump, the suction piping at the high end of the tank, and locate water draw off at the low end of the tank. C. Provide water draw-off lines within each of the tank for aviation fuel system. Arrange piping so that the fuel in the tanks may be recirculated through the filter. Separators. Primary tank constructed with the stainless steel is permitted when required. Require support channel with anchor holes, earthquake, hurricane, flood resistant down. Require steel to be minimum thickness of 3/16 for the interior carbon steel tank. Mount rectangular flat bottom tanks of 4,000 gallons or greater than 12 inches above ground to allow inspected maintenance of the tank bottom. Provide protective bollards in traffic areas. Bollards should not be less than 4 feet high, 4 inches in diameter, and steel construction filled with concrete or space not less than 4 feet on center. Require tank to be pressure tested after installation. Tanks shall be inspected in accordance with the SCI SP001 by the SCI certified inspector joint prior to commissioning. 7. Horizontal above-ground tanks. Protected tanks. General design consideration. When small 250 to 20,000 gallon tanks, above-ground storage tanks are required, there are clearance for the fire exposure problems. Additional costs be justified, and consider the use of the protected storage tank. The main advantage of protected tanks over single wall steel tanks are separate dyed contaminant may not be required. The vault with the system provides added measure for protection. Secondary containment type tanks can be used to provide spill protection control per NFPA 30. If the capacity of the tank is no more than 12,000 gallons, the tank size may be increased to 20,000 gallons. Class 2, Class 3 are used. All criteria of the National Fire Protection Association regulation. If appropriate, application must be met before secondary contaminant type tank will be used without separate spill contamination. Additional benefits include added protection for ballistic vehicular impact, reduced evaporation, volatile fuels, and warm climates. Required tanks to be factory and constructed with the 142 welded steel primary tanks. Tanks may be used in application where, in addition to the above consideration, construction separate tank for secondary contaminant purposes would have negative impact. Operation and aesthetics. Tanks located and close to the building and integral fuel dispensers must be UL listed secondary contaminant tanks, utilizing steel inner and outer tanks provide internal interstitial contamination which is both pressure testable and verifiable. Such tanks usually have a fill in regular insulating concrete. Ensure 2-hour fire rating meets and exceeds all requirements of the National Fire Protection Association 30A for fire resistant tanks and provide a minimum of 2-hour fire rating in accordance with UL 2085. Alright, tank design requirements. For flammable liquid insulation, require additional carbon contaminated based on tank fill ratings if there is chance of fuel spill entering critical area. Install tanks over the bottom of the slopes downward toward one end of the slope 1%. Locate transfer pump suction pipeline at the high end of the tank. Locate the water draw-off at the low end of the tank. Provide the water draw-off lines in each tank for the aviation fuel system. Arrange piping so that the fuel tank as much may be recirculated through the filter separators. Locate the water draw-off piping at the low end of the tank. For application not requiring secondary contamination, some of the residential heating tanks of the aesthetics may be primary concern considering protected exposed aggregated tanks of UL 2085 secondary contaminated protected rating without the outer steel jacket. A primary tank constructed stainless steel is permitted when required. Requires support channels to anchor holes, earthquake, hurricane, flood resistant tie down. Requires steel to be minimum thickness 316 with an interior carbon steel tank. Mount rectangular flat bottom tanks 4,000 gallons or greater and 12 inches above ground to allow inspection maintenance of the tank bottom. Provide protective bollards and tank traffic areas. Bollards should not be less than 4 feet high, 4 inches in diameter. Steel construction filled with concrete space not less than 4 feet off center. Require the tank to be pressure tested after installation. Tank should be inspected in accordance with the STI SP001 STI certified inspector prior to commissioning. Alright, above ground vertical storage tank. General design consideration. Provide cylindrical single wall seal above ground vertical storage tank meeting one of the following criteria as approved by the owner. Factory fabricated tank and complying with the UL 142 criteria. Diameter of the tank is limited by transportation restriction. Although these tanks are fabricated in size up to 50,000 gallons, they become quite tall due to the diameter limitation given in special consideration height diameter ratio to ensure tank stability. Field erected tanks are not requiring internal pan comply with the DoD standard design AW782427. Standard design includes a tank ranging capacity of 1,000 barrels or through 100,000 barrels. Requires the following design consideration for the tanks without floating pan inside, adaptive of the design team for the tanks larger than 100,000 barrels, use the multi-com API standard 650 design. Our field erected tanks complying with the DoD standards AW72 427. The standard and design include tanks ranging capacity with 5,000 barrels through to 100,000 barrels, with the internal pan required site adapting with a design team with the tanks larger than 100,000 barrels. One use multi-gallon AP standard 650 design. Required tanks to be inspected by the SCI registered inspector level 1 and level 2 certification API standard 653 certified inspector where applicable prior to the tanks being put into service. 8.2 tank roofs for tanks and internal floating pans design the roofs in accordance with the DoD standard AW782427. Internal floating pans, tanks containing Class 1 flammable liquid flammable fuels, mission critical Class 2 combustible fuels such as JP8 should be equipped with a full contact aluminum honeycomb floating pan. Other Class 2 fuels require a floating pan if the tank does not comply with the spacing and decking requirements. Tanking, storing, and mission critical Class 3 fuels such as JP5 and diesel fuel marine. 5 F-76 is located within a hot desert-like climate. Also require floating pan to eliminate the fuel-air interface. One slotted well used as manual measure shall be equipped with approved floating plug. The 8-inch slotted steel well with the automatic tank gauge system, leveling sensing device, and 6 inches minimum nominal space. Slotted steel welling of the automatic tank gauge system water probe are allowed to provide without floating plugs. For cone and roof tanks, floating plans provide roof vent inspection, hatches the fixed roof with the overflow with the port vents near the top of the shell near the device and the floating pan, which is and are sized for the manufacturer to evacuate air gas from the underneath the pan when the pan is on upon support during filling operations. Provide grounding bonds between the floating pan shell as follows: 2, 1 length of the bar, 3/16 within the diameter stranded extra flexible stainless steel wire rope extending from the top of the floating pan to the underside of the fixed roof, attached with 2 wires near the tank peripheral 180 degrees apart. Attach 1 additional third wire with the floating pan to the floating pan. 1 manhole cover. Securely connect the wires to the pan. Extend vertically to the tank roof and ensure the wires are accessible for the inspection. Ensure wires are long and they accommodate the full travel of the pan. Locate wires to miss all interior tank appurtenances and structures. Provide anti-rotation cables in accordance with the applicable standards. For cone roof tanks, floating pans provide gauge and sampling hatches in accordance with the applicable standards. F. Provide 36-inch diameter covered manhole in the floating pan. Tank bottoms. Slope of the tank bottoms downward in accordance with the applicable standard with a slope of 5% of the required for the positive drainage and self-cleaning action for the tank storing aviation turbine fuels. After tank construction is complete, perform a hydrostatic testing prior to tank coating. Conduct all tests and recommended the API standard 650-85 foundations. Design tank foundation on the basis of soil exploration program, including preliminary exploration and minimum detail exploration testing. If existing soil data is not available or inadequate, refer to UFC 322010 10N. Analyze, resolve the exploration program, determine the most practical and economical design to provide a stable foundation for the tank as the minimum use following criteria in all of the tank's designs. Prevent external corrosion of the tank bottom with locating of the tank bottom perimeters above the general tank field grade. Provide adequate tank field drainage away from the tank. Construct the foundation pad as specified with the ADW 72427. As minimum electrical resistance 5,000 ohms centimeter. Foundation material should be a neutral alkaline, pH greater than 7, a chloride concentration less than 300 parts per million, sulfate concentration less than 150 parts per million specified by the applicable standards. Sand may be washed and the pH may be raised to meet requirements. Include cathodic protection to prevent external corrosion of the tank bottoms. Do not use oil in the sand under the tank. Do not use dredge material or beach sand. Provide good drainage under the tank. Provide reinforced concrete ring wall foundation secondary contaminant. Locate the top of the foundation, minimum 12 inches above the dike base, and cover the area beneath the tank's fuel impermeable liner complying with applicable standards meeting local state requirements. Install all liners according to manufacturer requirements. Over liner, provide a minimum 12 inches compacted clean sand of similar materials described above. Securely attach and seal the liner to the inside of the concrete foundation ring with the wall beneath the tank shell. Provide a leak detection system in the tank bottom of the installing a pipe or pipe through the concrete foundation ring of the wall of the telltale of the tank bottom leaks. In the accordance with the applicable standard, these pipes are also permit water beneath the tank to escape by gravity. H. Perform subsurface investigations of sufficient detail to determine if any of the compressible, weak, organic, otherwise objectionable soils exist for the distance of the two tank diameters below the ground surface. Estimate magnitude rates of settlement at uniform differential seismic induced as part of the design. Provide adequate flexibility to piping and appurtenances. Other systems accommodate anticipated settlement. Accomplish flexibility by using pipe offsets and ball joints. Do not use corrugated bellow type expansion compensators. When objectionable materials exist, magnitudes anticipated settlements are sufficient to cause damage, unsuspectable distortion. Considerable subsurface improvement and potential improvement in techniques may be included removal of objectionable material, place and clean up compacted granular fill, preloading, surging charge. In conjunction, drainage, wicks, deep dynamic compaction, vibro compaction, stone column compaction, grouting, similar techniques. Where justified subsurface conditions are economic, consider using depth foundations such as driving pile, laying or drilled shafts. Alright, 9. Your underground horizontal storage tank. General design consideration. When underground storage tanks are 50,000 or less capacity, I'll use a factory-built horizontal cylindrical double wall tanks welded steel, fiberglass, reinforced plastic. Ensure that the contract requires design installation according with Title 40 CFR Part 289 for Initial Fire Protection Association 30. Any more stringent state local criteria require separation exterior tank walls, interior walls, both standing off, thus creating an open space and terrestrial for the monitoring of leaks. This is called Type 2 tank. Does not exceed 12 feet when the diameter of the tank limited tank length of 8 times of the diameter. Ensure that factory fabricated tanks comply with the UL 58 STI P3 criteria. Installation. Install tanks in accordance with the National Fire Protection Association 30 and all is strict in accordance with the manufacturer installation instructions. Install the tank at the bottom slope downward toward one end with a slope of 1%. Local transfer pumps and suction piping at the lower end of the tank. Provide straps anchors designed to prevent flotation of the tank located in the areas of high groundwater level and subject to flooding. Provide electrical insulation to strips, hold down straps, and metal tanks. Anchors may be concrete anchor slab under the tank concrete dead man. Place tanks in uniform bed homogeneous granular material at least 12 inches thick, and concrete anchor slabs may be placed minimum 6 inches for the bedding of the steel tank, 12 inches bedding in the fiberglass tanks between the tanks for the concrete anchor slab. Do not use block, chocks, or rocks. Ensure the tank is installed with a state-certified contractor if the state has a certification program. Ensure that the tank is installed with a contractor that is certified by the tank manufacturer. 10. Underground vertical storage tank cut and cover. General design consideration. Underground vertical storage tanks are steel line reinforcement concrete leak monitoring capability. These tanks may be completely buried surface constructed. They are covered with embankment. Any of the variation in between the design underground vertical storage tank in accordance with applicable standards except as modified herein. These standards include the tank tank inside of the 10,000 to 100,000 barrels capacity. In general, does not exceed 100,000 barrels capacity. Alternative design using prefabricated, pre-stressed tank sections must be approved by the owner. Provide leak detection underground storage tank in accordance with federal, state, and local law regulations. 11. Appurtenancies. Table 1 describes the appurtenancy atmospheric storage tanks, identifying the type of tank which they should be mounted. Full seal welded all tanks. Full seal weld all tank attachments to prevent moisture water from corroding tank shell and attachments. Alright, 12. Heaters. General design consideration. Provide tanker heaters control of the tank intended for the storage of high velocity products such as loops, oil, burner fuels, number 4, number 5, number 6 in climates where ambient tank temperature would be less than 20 degrees Fahrenheit. Above fuels pour point temperature, heavy burner fuel oils, lube oil temperatures at 20 degrees Fahrenheit above the fuel pour points prior to pumping. Use one of these type of heaters listed below. Heating medium. Use appropriate heating medium, particular application based on temperature, pressure, availability. Saturated steam is preferred heating medium, but consider using hot oil, hot water, electrical heating, whether steam is not available for existing sources. Convection type heating system installed with a storage tank capable of passing 36 inches of the diameter of manhole, capacity of the raise of the temperature of full tank burner fuel oil approximately 60 degrees Fahrenheit in 24 hours. The owner will determine the capacity of the heater could be reduced and not necessary for the heat of fuel tank of the fuel within 24 hours. Inline type. The inline heaters will consist of the two general tank suction straight tube. All inline heaters are shell and tube construction. Tank suction line, inline heater is installed inside of the tank along the tank issue line. Fuel oil enters the exchanger at the end of the tank and exists over the opposite outside of the tank. The steam overheating medium enters and exits the exchanger at the end of the outside of the tank. The straight tube and the pipe inline heater installed directly into the pipeline. Fuel oil enters the exchanger at one end of the exit from the other. The entry and exit point from the steam side can vary from the following criteria applies into the line heaters. Alright, capable heating of the fuel oil passing through the ambient tank temperature, minimum of 20 degrees Fahrenheit above the fuel oil's pour point temperature as required flow rate. Installed tanks all allow removal of heater tube bundles without emptying the tank. If multiple pass inline heaters are used, they do not allow the oil temperature to be raised to 30 degrees Fahrenheit per pass. Use carbon steel shells. Design a minimum 175 psi gauge or 1210 kilopascals. Cold working pressure on both the steam and oil side. Do not exceed 0.2 psi gauge from pressure drop of the oil side of the pump. Suction line not exceeding 10 psi gauge of the pressure drop of the heaters installed on the pump discharge. Alright, 12.5. Insulating and tracing. In the case where the fuels are heated, examine the possible economic incentive of the insulating heat of the storage vessels, piping. In many of the cases of the piping carrying heated products must be heat traced and prevent possible solidification of fuel during shutdown period. Insulate traced lines considering possible incentive of the insulating condensate collection and return system. If condensation return system is installed, include monitor to detect oil into the condensate. 13. Underground storage tank spill contamination system. Alright, 13.1. General design consideration. Provide drainage structure to impound escaping fuel where rupture of the underground tank is in a hillside location would endanger other activity structures at elevation lower than tank. Above ground tank spill contamination system. 14.1. General design consideration. Provide spill contaminant system above ground to prevent spill from petroleum from leaving the property. Individual tanks larger than 10,000 barrels. Capacity should be enclosed in a individual dike enclosure. Group tanks with no tank larger than 10,000 barrels. Not exceeding 15,000 barrels in aggregated capacity must be enclosed in single dike enclosure. Subdivided each dike each containing two more tanks and intermediate curbs to prevent spills endangering adjacent tanks with the diked area. Subdividing is required using intermediate curbs not less than 18 inches in height. Designer can take advantage of the exemption granted for the protected lines of the National Fire Protection Association 30 and 30A. If the provisions of this document are met, local, state, and federal regulations permit. Refer to the DOD standard design AW78 24/7. Using following criteria with the tank spill contamination system. Use preferred method of contaminated dike enclosure and impounding spilled fuel above around tank by means of the dike to prevent an accidental discharge of petroleum. As alternate diked enclosure used for the remote inbound spill collection system consisting of a series of drains leading from the storage tank areas to remote contamination impound is designed to prevent accidental discharge of the petroleum that is not preferred. There is required approval of the owner. Generally, the system is used for tanks on hillsides. Slope the area with contaminating not less than 1% of the carry the drain away from the tank of the sump located at the low of the point entrance enclosure. Ensure the drain line with the sump of the petroleum resistant and fire resistant. Improving this material. Do not use clay, concrete, fiberglass, plastic piping materials. Control drainage from sump to outside with an enclosure by eccentric plug. Valve indicator post located outside of the enclosure in an area that will be safely accessible during a fire. Do not allow the fuel to run off and escape with the contaminated area under any circumstances. Provide means of disposing, transmitting contaminated water from contaminated meat with the most stringent applicable federal, state, and local requirements. 14.2 Spill contamination system capacity. Dike enclosure. Design dike enclosure in accordance with the most stringent National Fire Protection Association 30 Title 40 CFR Part 112. Other federal, state, local regulations additional ensure the capacity of the dike enclosure minimum greater than largest tank volume located dike enclosure plus sufficient freeboard equal greater than 24-hour 25-year storm 1 foot over the entire area of the drainage other than flow of the water firefighting activities. 1. Appropriate environmental climates consider snow, ice accumulation as well. Limit the dike height to 6 feet or less. Alright, 14.2.2 Remote impounds. If approved by the owner and design, remote impounds according to the most stringent National Fire Protection Association 30, Title 40, CFR Part 112, and other federal, state, local regulations. Additional ensure capacity of the remote impound as a minimum greater largest tank volume located within the areas of the drainage flow water with the firefighting activity of the neighboring storage. Tank sharing spill collection system 1 plus the sufficient freeboard equal to the greater of the 24-hour 25-year storm 1 foot over the entire area of the drainage when inside of the remote impoundment can serve the total drainage area with all the tanks that are included with the spill collection system and appropriate environmental climates concerning the snow and ice accumulation as well. 14.3 Remote contaminant compound spill collection systems and construct with remote impoundment is generally described as the dike enclosure, earthen dike type construction. Earthen dike types are either earthen material with a fuel impermeable liner can cover where spaces are premium. Construct dikes of vertical concrete walls for either dikes and make the minimum distance of the toe to the dike of the tank foundation 5 feet with a provided flat of the top of the dike at least 3 feet. Why did not make an earthen dike slope steeper than 2.5 horizontal to vertical 1 to vertical? If space or restricted direct slopes may be increased to 2 horizontal, 1 vertical if slope dikes are constructed concrete surface. Cover sides of the top of the earthen dike and the floor around the tank with one of the following materials. Facility plate 0119. Fuel impermeable liner. Liner is exposed with the exposed area for the most resistant effect for the direct sunlight and wind uplift that provides sandbags in accordance with the appropriate Unified Facility Guidelines. One other approved liner manufacturer 1, 2, and 1 to ensure liner is resistant to wind uplift for all liner manufacturer recommendation protect the liner. They use the geotextile cover. Other recommended means provide a concrete maintenance pad with a personal access of the tank for work areas around the tank manholes, valves. Do not use bentonite or bentonite composite material in construction of dikes and basins. Do not use asphalt. Alright, 14.5 Dike enclosure reinforcement concrete dike type design. Reinforced concrete prefabricated cast in place dikes on the foundation resist conduct and full hydrostatic loading with a full filled capacity. Conserve the use of the reinforced concrete blocks with or without exterior either mounting earth mounting. We use vertical reinforced concrete dikes where space is premium. Seal all concrete surfaces with a flexible UV resistant, fuel resistant coating if required. Local state regulations use fuel impermeable liner as described above with the dike floor. Dike enclosure combination dike type. The vertical concrete wall banked with the external earthen berm may be used designed with a combined earthen and concrete unit of the foundation resist that contain all full hydrostatic load when filled with capacity use fuel impermeable liners described above the dike floor. 14.7 The stormwater collection system design. Stormwater collection system to contain the transport, treat, and discharge any stormwater that collects in the tank with an enclosure. Review state and local regulation with the design requirement permitting of the stormwater treatment system. Dike access. Provide concrete, steel, aluminum steps for the pipe and handrails. Passage across the dike steps and handrails must comply with the Title 29 CFR Part 1910-36 include removable section of handrails to provide access to the flat top of the earthen dikes. If steel steps are used, they should be hot dipped and galvanized after fabrication. Provide enough in access to the location to save the emergency egress for normal operation. This would normally include the step of the dike separating adjacent tanks as well on one wall without adjacent tank. Locate steps in most accessible points, preferably on the same side of the access stairs of the tank roof. For tanks 1 to 1 to 10,000 barrels, larger considerable, providing earth-filled ramps to permit vehicle access dike when approved by the owner. If there is sufficient need to provide vehicles across any dike into the dike area, provide a concrete paved road, earth-filled ramp for vehicle travel ways for remove steel bulkheaded section may be cost effective. Method to provide access to the dikes: vertical reinforced concrete walls where the vehicle access road crosses the dike, provided a security gate and predominant sign indicating the access is limited to 1-ton pickup truck compliant with National Fire Protection Association 70 Class 1 Group D Division 2 criteria. Alright, 15, miscellaneous use of tanks. The paragraph provided design guidance for miscellaneous use tanks. These tanks are typically less than 550 gallons in capacity. Check state and local law regulations before beginning design. If miscellaneous use of tanks capacity greater than 12,000 gallons, the following requirements of the table. Otherwise, use standards described below. 15.1 Installation. Install tank conformance requirement of National Fire Protection 30 exemption. Even the deletion dike contaminate with acceptable. All criteria associated with that exemption are met. Provide contaminant with all the tank regardless of size, except for the small residual heat tanks, oil tanks, and complying with the paragraph tilted with the above ground still tank spill contaminant system in chapter of the UFC using the properly installed above ground concrete encased tanks in accordance with the paragraph titled Horizontal Above Ground Tanks, Protected Tanks. 5.2 Heating oil tanks comply with the National Fire Protection Association 31. Generator fuel tanks comply with the National Fire Protection Association 31, 37, and 110. Fire pump fuel tanks comply with the National Fire Protection Association 20, 30, and 31. Waste oil tanks check local state environmental regulation for any of the additional requirements for the storage and waste oil. 5.6 Contamination. As discussed previously, chapter provided contaminant under and all above ground tanks except the home heating oil tanks. Underground tanks. Ensure all underground tanks are double walled and have overfill protection as described below previously. Alright, 16. Ship off-board fuel storage tanks. Function: additional regulatory storage. Conserve the storage tank of the fuel removed from ship that may be off specification, otherwise not satisfactory for use. Intended use: the fuel may be downgraded with the heating oil with the diesel fuel. Marine. General design consideration: determine the volume requirements of the contaminated fuel storage tank with the active survey. Provide the bottom loading facility of the tank and truck loading, offloading contaminated fuel. Location: located with the contaminated fuel storage tank and near the facility of the tank farm. Clear mark the tanks as to the type of the grade of the fuel. Jet engine and test cell fuel storage tanks. Design jet engine test cell fuel storage tank. Issue system standard as operating storage tank fuel system, high level alarms, gauging, shutoffs, etc. Normally the tanks are refilled with using station aircraft refueling tracks through aircraft single point refueling adapters. And it shows the item's manhole and appurtenances. Inspection of hatches and ladders. Tanker cars greater than or less than 30,000 gallons. It's a table. Tanker cars 30,000 gallons or more. Product recovery tanks. Open atmospheric gauge and gauge hatch still Willings. Lowest piping connection, overfill protection, water draw off, ball joints, cable support, striker plates, monitoring port. Then we're gonna just this shows your integral valve thermal relief piping, double block and bleed, manual body drain from tanks, manual drain line pipe to protect the recovery system. Other approved collection method: thermal discharge, thermal body relief, double block and bleed plug valve. Thermal pipeline pressure, differential pressure relief towards the pressure system, main body drain, welded neck, typical flange. This shows your conventional thermal relieving piping system. Shows the from the tank secondary containment and seal insulating strainer isolation, welded neck, flange, threaded outlets, ball type valve. thermal discharge, union thermal relief valve, pressure gauge, typical system product valve, product flow, pipe support, small lines, equipment controls, and slab and curb. Once again, check type valve, plug valve, deaerator, fuel tank offloading, refueler, fuel tank storage, internal thermal release piping system for from fuel storage tanks to fuel storage tanks, from incoming pipeline control valve, equipment pump house or pads. Check valve to pump valve, pipe valve, ball valve, conventional thermal relief piping system, control valve, integral valve, thermal relief piping system, plug valve, typical filter separator, typical to the pump house, tanker truck, refueler, equipment racks, plug valve, typical storage tank suction line, integral thermal piping system, and conventional thermal piping system, tank fill line. Canopy, double hose production, dual housing, double hose, quad housing, control, equipment in the pads, fueling area, asphalt pavement, way traffic flow, double product, quad dispensing room, dual product, dual hose, dispenser, asphalt pavement, vehicle motor fuel station plan. Canopy loading equipment, one-way traffic, asphalt pavement, asphalt, concrete truck, equipment pads, contaminated area. Control it, contaminating area, contract remote spill control system. Your grounding rod, dead man control, grounding verification, overfill protection with loading hose and nozzle, hosing reel with a reel, self-retracting electric motor driven retractor, followed by the meter flow straightener, control valve card, operational strainer, double check bleed valve isolation. Surge suppressor, fusible link safety valve not required in the Air Force loading system with a hose reel. Then from the loading hose with loading nozzle covered over the storage rack, grounding reel, grounding verification, overfill protection, dead man control, meters flow straightener, control valve strainer, guard reader operating surge suppressor required, double block and bleed isolation valve, fusible link safety valve not required, Air Force projects, loading system with hose. Your overflow, 100% set at overflow, and then roof vent inspection hatch, internal floating pan, 0% floor to shell joint, vertical above ground tank with floating plan, 100% roof to shell, roof venting inspection hatch, using suction C note 3 floor to shell joint. 1 would be your low level alarm, 2 low level alarm, 3 high level alarm, 4 high level alarm. Alright, tank shell pipe ground around the oval distribute transmission, oval pipe diffuser fuel discharger. Tank shell floating pan, TRV, WNFL, typical of the fuel sample type, shell penetration, floating pan, meter, tank bottom slope, interior pipe support, and that's above ground vertical storage tank inlet fuel connections. Offset valve maintenance, accessibility flow valve pill, hydraulic diaphragm, high level shutoff valve, double wall contaminant pipe, 36 by 36 access lead, grade turbine enclosure, fill drop tube, striker plate and double wall storage tank, horizontal above ground pump fill connection, grade gravity fill connection, 5 gallon spill contaminant sumps, dielectrical bung connection, vent line, floating vent line, overfill valve, not to be used with pump fill connection, fill drop top, striker plate, double wall storage tank, horizontal above ground, underground gravity drop fill connection. Your access platform handrail to high level shutoff valve floating pilot, high level floating pilot valve connection, conventional thermal relief piping, tank valve, fire safe flow, double flange tank nozzle, slope down 1%, fill diffuser slot each side 10 feet seconds, hydraulic operated diaphragm high level shutoff valve, slope half coupling, drop off product recovery system, aviation turbine fuel, horizontal above ground pipe pump fill connection, and then it goes into the exam. And we skipped the this chart right here, the table 1, but we'll see how we come out. That was an introduction of a petroleum fuel facility atmospheric storage tank. It was by J. Paul Geyer. It was described out of the UFC's. So let's go ahead and take